Hey, hi friends. Welcome to today's video. Today we are going to discuss one of the important questions which is generally asked in interview is like what is the difference between equitable, comparable and Hashable protocol. So we'll go through all of these three one by one and we'll see that in which scenario we should use equitable, comparable and Hashable and how they are different from each other. So first is what is equitable protocol? Now if you see the Apple's documentation, it is written that a type that can be compared for value equality. Now let's say that in this particular example, what I have done, I have created a simple student struct which have two properties. One is name and one is marks. Okay. Now I have created two objects. Now let's say that if I have to compare two objects, whether they are equal or not. So one way is what you can do. You can just write a if statement like object one dot name equals to object two dot name, and I just copy and paste the same thing and replace this with marks. So if both are equal, then this object is equal. Now what if your struct contain 10 properties or 12 properties? Or what if let's say that your struct have another struct like child struct? In that case, this if approach is going to be very complex, like we always prefer to write cleaner code. So now to solve this problem in a better approach, what we can do, we can confirm this struct class to equitable protocol. Okay. Now the moment you write this equitable protocol, now what will happen? Let's first go to the definition of this equitable protocol. So if I command click on this, so this is a equitable protocol and see if this has just one method. Okay. Now when I confirm to this, the struct don't ask me to implement this method, means by default it's implemented the way how we have the default designated initializer which is present in the struct. Okay, so once we confirm to this equatable, now I will be able to use like object 1 equals to object 2, like this I can write, and then sorry, and then I can just write that object are same. Okay, so right now if I run, obviously the object are not same because the name is Nilesh and one is Ramesh. So let's do one thing. Let's make both as Nilesh and let's make both marks also as 90. Now if I run it, it will print me object are same because the object are same in this particular case. So but is it like now I have shown you that there was a method here, but do we require to implement this method in this case? So yes, we require when you don't want that every property has to be compared. You let's say that you want out of 10 or 12 property, you want just one or two properties to be compared, or four or five. In that case, you can implement this method and then you just compare the property what you want. Let's say that I just want to compare marks in this case. So I'll just write RHS dot marks. Okay. Now in this case, even if I change it to Ramesh and let's first keep marks different. Now if I run it, nothing is printed because marks is also different, name is also different. Now I'm making the marks as same, and in this case it will print me object are same because now I'm forcing my compiler that you just compare marks, you don't compare the whole properties. Okay. Now this secure protocol will behave little bit different in the case of class, and here where the interviewer will like try to confuse you. To I just remove this equatable protocol and remove this also and change this struct to class. Now, the moment I do that, this will give error because class don't have designated initializers. So if somebody asks you what is the difference between class and structs, apart from saying that struct is value type, you have now one more difference that class don't have designated initializers by default, struct have designated initializer by default. So here let's create a designated initializer. So init, and then I'll just use the same thing here very fast, and then self dot name equals to name and self dot marks equals to marks. Okay, so now all the error will go away. Now let's confirm, because obviously I'm not confirming into equitable protocol, this error is there, but let's now confirm to equitable protocol. Now in the case of class, it will throw you error. And what's that error? That it will ask you to implement that method or the equality method at any cost. So in the case of struct, it was optional until unless you don't want the whole your properties to be compared. But in the case of class, it's not like that. So keep this point in mind. This, no, like sometime they are, no, the interviewer might try to trick you in this point. So here I'll just do the same thing. Let's say that let's say that I want to compare everything. So LHS dot name equals to RHS dot name, and I can just give a and symbol, and let's copy and paste it here and replace the name with marks. Okay, now if I compare, it will not print anything because marks is same but name is different. So let's make the name also same, and in this case the object will become equal. Okay, so this how you see that equitable protocol. You can use it for both struct and the class. Okay. Now let's see what is comparable protocol. Okay, now I'll delete this also. Now instead of equitable, if I write comparable, so if you see the comparable protocol, a type that can be compared using the relation operator. So here you have what? In the case of equitable, you have equals to operator, and in the case of comparable, you have less than equal to, greater than equal to this. Okay, so now once you go to this protocol, let me just jump to the definition. So here you see less than, equal to, greater than, greater than. Okay. Now in this case, you have to confirm to at least one method, not all. Like you can implement all the method based on whether less than, greater than, less than, equal to, but one is mandatory. So here I'll just return LHS dot marks less than RHS dot marks. Similarly, you can implement all the method. So let me just cut it and paste it down. Second, I can just use a greater than or less than equal to. You can use everything. Now here, in this case, instead of, now if you see, it's not giving me error of equals to symbol also, because if you go to the definition of comparable, it is conforming to equitable protocol. So it have the equitable protocol functionality as well, and that's the reason the object one, object two symbol will still work. Okay, so now what I want to do, that I want to compare if object one greater than object two. Okay, and I want to print object one is greater. Okay, I'm just removing this sentence. Now if I run it, you will not see any output because marks is same, so it's not greater. Now I'm making this one as, let's say, 40. Now obviously my marks is greater, so this time you will see that object 1 is greater. Similarly, you can use the same thing for the less than equal to. Okay, so you can use comparable protocol to easily compare to struct, to class with less than equal to, and greater than equal to. Okay, so this is all about the comparable protocol. So got it? Equitable for comparing, for equating two values, comparable for comparing in the terms of less than equal to, greater than equal to, and comparable also conforms to equitable protocol. Now let's come to the last one, Hashable. Now Hashable is not that much used in, no, like the way we use equitable and comparable protocol in our real-time implementation. But let's see that first, understand what is basically Hashable, and then in which scenario you can use Hashable protocol. Okay, so let me delete again this thing and confirm to the Hashable protocol. Okay, now if you read the definition, a type that can be hashed into a hasher to produce an integer hash value. Okay, now I'll tell you what is this integer hash value. Okay, now let's remove this comparison because now we are not comparing, and what I can do, I can print a hash value of it. Okay. Now, similarly, I can print a hash value for object 2 also. Now, if I run it, what you'll see two integer value. And every time you run it, this integer value will be different. Okay. And this integer value is basically based on the value what that particular struct or class contains. So, for example, in this case, let's say that if I make two object identical, that means object 1 having name Nilis marks 90, object 2 having name Nilis marks 90. Now in this case, hash value will be same for both the case. Now every time I run, it will be different, but as the value is same, it is same. Okay. Now, how does the Apple calculate says there is some logic in behind, but yeah, can we play with the hash value? Like, can we change the hash value, or can we do something trick about it? That we can do it. Like, we can tell the compiler that what you need to consider while creating this hash value. So right now, with the default implementation, the compiler is taking consideration of name, marks, or whatever the properties you have. Or let's consider in this case, you don't want your marks to be deciding factor for creating your hash number. So for such scenario, what you can do, you can, if you go to the hashable method, so here, see it has two things. One is a hash value, which we are using. It's a read one, and this is the method. Okay. So if you see the definition, let's copy the whole thing and let's bring it here. So the hasher to use when combining the components of the instance. So by default, as I told you that it combines all the instance, but let's say that I want to combine only name. Hasher dot combine, and I want to just combine name. Okay. Now, see right now what was happening, that name and marks both were same, and that's why the hash value was same for both the object. Okay. Now I'm making the marks different, but then also if I run it this time also, if you see, the hash value is same, because now I'm telling this hash using this function that you just use the name to determine the hash value. You don't use marks. So, and in this case, if name is same, that's why it is coming out to be same. Now if I change this name to Ramesh, obviously in this case it's going to be different hash value. Okay. So you can use this function to manipulate the properties which you want, no, your hash value to be to be calculated. Now why, one of the reason that we don't use hash value, uh, you, one of the reason is that why we don't use this hash value, because every time when you compile the application or every time you run it, the hash value changes. So you cannot like compare, like let's say that if I'm comparing it for my future uses, it doesn't make sense, because it might happen that your hash value what was the previous, it got changed, and in that case you can get some no, weird result. So instead of comparing something, we should always prefer comparing using equatable or comparable protocol instead of using the hash value. Okay. Now let's see that one error which you might have seen but you might have not noticed is, I'll just show you that. So let's say that if I create an array of my student, very simple use case I'll tell you, that which you will you will see in your real-time project implementation for Hashable protocol. So basically Hashable is used in the dictionary sets, where you have the key value concept. So it's basically a mapping, like for every value there will be a number which is kind of a unique thing for it. Now when I create an array and I run it, there's no error. You see, there's no error at all. Okay. Now what I'm doing, I'm deleting this, and I'm deleting this also, and I'm deleting this also. So, so now this is a normal struct, and I'm just creating array of it. There's no error, nothing. But now I write another thing, that is where set equals to set of student. Now, the moment you write it, you will get an error. See, and this error you might have seen at multiple places that some type does not conform to protocol Hashable. Now, to solve this, as I told you that if you see the Apple's documentation, sets and dictionary, store your custom types in sets using this them as a dictionary keys. Protocol Hashable. So these are basically used when you're using no, when you're using sets and dictionary. It has to conform to this Hashable protocol, like the key value pair concept. So here I was creating sets and my struct was not conforming to it. So in this case, I should use this hashable concept. And now another question which is generally asked that why I should use set over array, because set have more performance capability over the array, because in if you want to search a item in an array and if you want to search an item in a set, it's very faster when you're using set. So let's say that when you are dealing with a large amount of data or large array, so instead of using array you should prefer using set in that particular case. And in that particular scenario, you have to confirm your struct to the Haswell protocol. Okay, so that's all about today's video, that how we see that how what is the difference between equitable, comparable and Haswell protocol. Hope you like this video, and if you really enjoy this video, don't forget to subscribe the channel and leave your feedback. Thank you.